I believe there are five key factors which has gone in favor of DeepSeek, and first and foremost is that cost efficiency. So it could train its model with just investing 5.58 million US dollar, whereas OpenAI invest around $6 billion. Then comes the hardware efficiency. You can see that they have trained the model using just 2048 NVIDIA H800 GPUs for 2 months. We do not have figure for OpenAI, but Meta has targeted to build uh, compute power of 600,000 powerful NVIDIA H100 GPU by end of last year to train their next LLM. H100 GPU, NVIDIA H100 GPU is far more superior than H800 GPU, and you can see the numbers. It is 2048 they have used, and Meta have targeted for 600K GPU for the next LLM. Then training hours, again a DeepSeek V3 model, the base model for DeepSeek R1 got trained using 2.78 million GPU hours, whereas we do not the figure for OpenAI, but we have a figure for Llama 3 which used 30.8 million GPU hours, which is again more than 2.78. Then parameter wise, DeepSeek R1 is smaller compared to GPT-4o model. You can see that it has just have 671 billion parameters, whereas GPT-4o, which is one of the OpenAI model, they do not publish their architecture in that sense. So it is a market estimate says that it has almost 1.76 trillion parameters. It is a huge model, and we are comparing here DeepSeek R1 with O1 model of OpenAI, which is which is superior to 4o, because O1 model has the reasoning capacity, and I'm estimating that would be more or less similar to 1.76 million trillion parameters. Then type of model wise, DeepSeek again is open source, and whereas OpenAI is proprietary. So you can download the model. If you have that heavy system, you can download the model in your own system, and you can use that for your own purpose without paying anything apart from your system cost. But OpenAI O1 mini model, you can just use that by accessing their API and by paying them, and you can't fine tune the model as well, whereas you can do that with DeepSeek. Next, let's go to the API cost. 1 million tokens input price. DeepSeek charges $0.14 if it hits the cash, and OpenAI O1 mini charges 1.50 US dollar for the same number of tokens input. And if the cash gets missed, then DeepSeek R1 charges 0.55 US dollar, whereas OpenAI O1 charges 3 US dollar. Again, it is more compared to DeepSeek R1. Then for 1 million tokens output price, DeepSeek R1 charges 2.19 US dollar, whereas OpenAI O1 mini charges 12 US dollar. So again, here you are getting almost the same output with very less price. And this is the benchmark published by DeepSeek. They have, you can see that uh, DeepSeek models, DeepSeek R1 models, and their 32-bit model, they are almost at par with OpenAI O1 models. So performance benchmark perspective also, it is almost better or at par with O1 mini model. Okay, next I'd just like to explain the reinforcement learning in very simplified manner, so that before I go to the architecture, it becomes helpful. So reinforcement learning is a concept where actually you have agent, and then you have action, you have rewards, you have penalty, and uh, with all these things, your main target, you have an objective. So let's say if you imagine this maze, and then this is your objective to get this diamond, and this is the area where actually you get penalized for reaching out this. So if you just directly go to that, you may be penalized with -10 or -50, something like that. And if you reach here, then probably you will get +10. So this agent actually try to the main objective is to learn how to get the shortest way to reach to its objective. And in this entire process, it may go here, then it realize that this is the bad path. It may go here to realize that this is the bad path, and in this way it finally learns how to reach out here. And this reasoning, actually it is learning by himself. No one is telling it what is the good data, or what is the good path, or what is the bad path. It is learning by exploring himself, which is the bad path and which is the good path. And that's how it is developing the reasoning sense, and it is finally reaching its objective. So this is what reinforcement learning in very simple manner. Let's go to the architecture then. So I went through the research paper which they have published. They have their base model, which is a DeepSeek V3. It is as comparable to the GPT-4o model of OpenAI. And what they have done, they have first cold started this model. That means like they have fine-tuned this model with chain of thought data. So chain of thought data means you can think that like as a human, if I try to solve some problem, I'll go through some steps. I'll follow some steps to solve that problem. So it is kind those. So chain of thought means those are the steps to solve some problem. So it is fine tuned with that kind of data, and after that it produces a cold started model, and that cold started model goes through the reinforcement learning. And that reinforcement learning, it has objective to improve the reasoning capabilities. So this is the objective, and the rewards are defined like if it produce kind of accurate response, format is correct, and language consistency. This is one of the major point, because this first started with DeepSeek R10 model, and in that model they tried to actually uh, implement or fine tune the base model, so DeepSeek V3 model, with reinforcement learning. And that was a kind of novel approach, because no one tried that particular way earlier. So while training that base model with reinforcement learning, it definitely uh, did good, but problem was that it was not able to give the response in a proper manner, in a sense like it was mixing the language. So different languages were getting mixed while responding, and also the response was not in a readable format. So then they started with this DeepSeek R1 architecture, and where actually they in the reinforcement learning, they started giving the reward if the language consistency is there, like if they're following the same language while responding. And once it gets tuned with the reinforcement learning, it generates a checkpoint output, and that checkpoint output is used by a rejection sampling method to produce a reasoning data, which is a very good supervised fine-tuned reasoning data. And that data, with along with that data, some non-reasoning data also gets combined. Non-reasoning data means it may be kind of factual question answers, then writing, etc. So now they have reasoning data, that is output of their rejection sampling, and then non-reasoning data combination of that data now gets used uh, to do a supervised fine tuning. So this time they are going through a supervised fine tuning to that checkpoint model, the same model here, and this is get further tuned, and they have now a fine tuned checkpoint model. And this particular model further goes through reinforcement learning steps again, and this time objective is that generate responses which is more aligned with human preferences, and rewards are like helpfulness means readability is much better, or harmlessness means there is no harmful information, and better reasoning. So these are kind of rewards have been given if for in this reinforcement learning approach. And finally, after this stage, it produced our most coveted model, DeepSeek R1. This is not as simple as I have drawn it here, but these are the major steps you can think. Means if you just want to understand the architecture in a very high level manner. So what I would suggest that if you want to do deep dive, please go through their paper. They have mentioned that reinforcement learning algorithm in beta, and they have described this in more detail. If you're interested, definitely go through that. So this is all about the architecture. Thank you for watching. Please do like, subscribe, and share, and don't forget to leave your comments regarding feedback and suggestions. Thank you again.